Hey kids, so want to show you a cool experiment here. Right here I have the business end of a Van de Graaff generator. Over here is a conductive sphere, and it is attached to the plumbing fixtures in the room. So it is attached literally to planet Earth, the biggest sphere around. Okay, that keeps this permanently neutral. This can, well, now that I'm touching the plumbing, it too is neutral. Once I turn this on, now that'll probably electrify this immediately and make this negative, but I'll touch it again and it'll be neutral. So what is a neutral object going to do in the presence of a strong electric field? You might first be tempted to say, no, it's not going to do anything. But the idea is simply this. Can electrons move in this? Well, of course they can. Which means if I have them next to a strong negative field, the negative charges are going to move over to the far side of the can, leaving the near side positive, which will make it attracted to this. And because even though it's a small distance between the positive and negative here, so you might tend to think it's not going to be too attracted, please remember it's the inverse square law that we use to determine how attracted or not it will be. And because a small distance, when you square it, turns a lot bigger, the inverse square law ensures that this is going to be strongly attracted to that. Well, what's going to happen when it touches? Well, then it's going to fill with electrons. Then what? Well, then it's going to be repulsed by this. Where to go when you're filled with electrons? Oh, how about that neutrally charged sphere, where you can induce the negative charge here, positive charge here, so this will swing over and touch that. Then what happens? Loses all its electrons, which go right into the Earth, which will never reject the electrons. Then, this is neutral, this is neutral. Gravity takes over, swings down. Then it's neutral near this. And you can see the process will repeat itself. Ben Franklin actually had something like this in his house. This would have been attached to a rod on the roof with a clanger that was neutral next to it, with a ball here attached to the rod on the roof. This ball would be attached to the ground. And it turns out when a thunderstorm would come up, this device would start ringing and let Ben Franklin know there was a thunderstorm coming. So let's try it. All right? So I have to neutralize that. There you go. This will go all day. In the bottom device here, you could see also a bunch of particles that are, when they're neutral, they're attracted to the top because the top gets a big electric charge on it. And once they touch the top, they become negatively charged, so down they go. So this is constantly raining. Those are little insulated particles of vermiculite. And this device that ends up spinning all day is shooting a little plasma jet out of it from the point there as it negatively charges. It's able to squirt those electrical charges out, so it is constantly spinning because of that plasma jet. Nothing but fun here in the physics lab. Enjoy. Have a good day.